In August of 1977, something strange happened in the quiet countryside of Ohio. At the Ohio State University Radio Observatory, a massive radio telescope called the Big Ear was scanning the sky, listening for signals from deep space. Most of what it heard was static, cosmic background noise, the normal hum of the universe. Until suddenly, it wasn't. For exactly 72 seconds, the telescope detected a radio signal so powerful and so unusual that it immediately stood out from everything around it. It wasn't random, it wasn't noise. It followed a precise frequency, one astronomers had long believed could be used for interstellar communication. When astronomer Jerry Amons saw the data printed out on paper, he froze. He circled the signal with a red pen and wrote just one word in the margin: "Wow." That single note would give the signal its name forever. The wow signal came from the direction of the Sagittarius constellation, near where astronomers believe the center of our galaxy lies. It was strong, clean, focused. And then, just as suddenly as it appeared, it vanished. The telescope kept listening. Nothing. Scientists expected it to return. They assumed it had to be something explainable. A satellite, a passing spacecraft, maybe interference from Earth itself. But none of those explanations held up. No satellites were in that position. No known stars or cosmic events matched the signal's characteristics. And no matter how hard astronomers tried, the signal never repeated. Not once. For decades, scientists have pointed telescopes back at the same region of space, hoping to hear it again. Some even devoted years of observation to that exact patch of sky. Silence. That's what makes the wow signal unsettling. Not just what it was, but what it wasn't. It didn't behave like natural cosmic noise. It didn't behave like anything we've catalogued since. It behaved like something intentional. And then it stopped. Which leads to the question that still unsettles astronomers to this day. If something out there tried to say hello once and never again, what made it stop? Was it a coincidence? A rare cosmic fluke we happened to catch at the perfect moment? Or did something realize it was being heard? The universe has been quiet ever since, and sometimes the silence is worse than the sound. In 1997, scientists listening to the ocean heard something they weren't supposed to. At the time, NOAA had underwater microphones, called hydrophones, spread across the Pacific Ocean. Their job was simple: listen for earthquakes, volcanic activity, and anything unusual happening beneath the surface. Most of what they heard was predictable: tectonic plates grinding, ice cracking, the deep, constant noise of the earth shifting. Until one sound broke through everything else. It was massive, low frequency, and so loud it was detected by sensors more than 3,000 miles apart. They called it the bloop. The sound rose slowly, peaked, and then faded away, lasting just over a minute. But what made it terrifying wasn't how long it lasted. It was how powerful it was. The bloop was louder than earthquakes, louder than volcanic eruptions, louder than anything ever recorded in the ocean. And it didn't sound mechanical. Scientists immediately tried to explain it. Could it be a secret military test? No known technology could generate something that's strong underwater. Could it be an iceberg cracking? Possibly, but the sound didn't behave like ice. Then came the unsettling thought no one wanted to say out loud. The frequency matched something biological. For years, researchers quietly considered the impossible, that something enormous, larger than any known animal, had moved through the deep ocean, far beneath the surface, where sunlight never reaches. To put it in perspective, for an animal to produce a sound that loud, it would have to be bigger than a blue whale. Much bigger. And whatever made the bloop wasn't near the surface. It came from the depths near Antarctica, one of the least explored regions on Earth. Eventually, scientists publicly settled on an explanation: icequakes. Massive ice sheets cracking and shifting as they break apart. But even today, that explanation doesn't sit right with everyone, because ice doesn't move like that, and ice doesn't sound alive. The bloop was a single event. It's never been recorded again in the same way. No clear source was ever identified. Just a sound, too powerful, too deep, and too strange. Whatever made the bloop was louder than earthquakes. And for a brief moment in 1997, it reminded us of something uncomfortable. We've explored more of space than we have of our own oceans, and the deepest parts of this planet are still listening. out in deep space, there's a star that never shuts up. It's called PSRB 0329 plus 54, and on paper, it doesn't sound that frightening. It's a pulsar, a dead star, the collapsed core of a massive sun that exploded long ago and left behind something incredibly dense, incredibly small, and incredibly fast. But when astronomers decided to translate its radio emissions into sound, everything changed. What they heard wasn't static. It wasn't noise. It was a sharp, high-pitched shriek, metallic and rhythmic, repeating over and over again. Not randomly, not chaotically, perfectly spaced. Like a scream trapped in a loop, pulsars spin at unbelievable speeds. Some rotate hundreds of times every second, sending out beams of energy as they do. Each time that beam sweeps past Earth, our instruments pick it up like a lighthouse cutting through darkness. PSRB 0329 plus 54 does this with frightening consistency. It misses beats less often than an atomic clock. That precision is what unsettles astronomers. Stars aren't supposed to keep time like this. Natural objects wobble. They slow down. They drift. But this one doesn't. It pulses again and again, as if something is winding it, maintaining it, refusing to let it fall out of rhythm. When the signal is converted into sound, it stops feeling like astronomy and starts feeling like surveillance. A mechanical scream echoing through space, repeating endlessly, indifferent to whether anyone is listening. And the worst part is how long it's been happening. This star has been screaming for millions of years, long before humans existed, long before Earth looked the way it does now. Every pulse perfectly timed, every shriek identical to the last. Astronomers understand how pulsars work. They can explain the physics, the rotation, the magnetic fields, the energy release. But understanding something doesn't make it feel less wrong. Because when you hear it, when you actually listen, it stops sounding like a dead star and starts sounding like a signal that never expected an answer. It's been screaming into the dark for longer than we've been capable of hearing it, and the universe never told it to stop. It's still screaming now. For a long time, we believed black holes were completely silent. They swallow light. They trap matter. Nothing escapes them. Not even sound. At least, that's what we thought. Then astronomers studying the Perseus cluster noticed something strange. Using NASA's Chandra X-ray Observatory, scientists detected enormous pressure waves rippling through clouds of superheated gas. These waves weren't random. They were expanding outward from the center of the cluster, right where a supermassive black hole sits. The black hole wasn't just pulling things in. It was pushing something out. When those pressure waves were translated into sound, the result was unsettling. A single, deep tone, so low that humans could never hear it. 57 octaves below middle C, the lowest note ever detected in the universe. It's not a sound you hear. It's a sound you feel. That tone has been echoing through the Perseus cluster for millions of years, slowly rippling through gas that spans hundreds of thousands of light years. The black hole sends out these waves again and again, like a slow, steady pulse, like breathing. Black holes are usually described as violent, chaotic things, cosmic destroyers that tear stars apart. But this one behaves differently. It hums, constantly, methodically, as if regulating the space around it. Astronomers believe the sound helps control the temperature of the surrounding gas, preventing it from cooling too quickly and forming new stars. In other words, the black hole isn't just ending things, it's maintaining balance, and that's what makes it uncomfortable. Because breathing is something we associate with life, with awareness, with presence. Yet this sound comes from something that should be completely dead, something that shouldn't produce anything at all. If no one had translated those waves into sound, we'd still think the universe around black holes was quiet, still imagine them as mute voids drifting through space. But they aren't silent. They hum, slow, deep, and endless. A reminder that even in the darkest places in the universe, something is always moving, always pulsing, always listening.